Okay, we're going to go ahead and do the experiment using this board, and we're going to rise it up very slowly until it begins to slide. There's a protractor here. This board is affixed there. I'm going to rise it slowly so there's no friction that I can get up, so there's no interaction. And I want to see when it first starts to slide. So I'm about 13 degrees and I saw it sliding. No need to do it because I'm interested in getting static friction. Okay, but here's the trick. You want to get good data. So every time you rise it, you're putting energy into the system that could knock it out. So you want to bring it up to about, let's say, 10 degrees, where you know it won't slide. And then you have 3 degrees to play in which you could be putting energy into the system, but it'll be a lot less to see when it starts to slide. And it's about 13 degrees. So I would go ahead and repeat this one a number of times, like 5 times, 6 times, on large felt. Then I would do this again on small felt. If my contention is right, then when we do this, I should be able to get the same values. So here I am at 70 on this, and I'm very, very, very slowly raising it. And I'm just going to bring it up to about 10 because I'm pretty sure I'm right. I've got this small felt on here. And that's close to 12 and a half. So not quite the same. Nothing's ever perfect. Maybe I was shaking it too much. I'd need to repeat the data. But in this way, we can assure ourselves that we're being careful. I would then repeat this for large wood, small wood, 5 times, 6 times, maybe even 10 times each, depending on your time that you've got for the lab. Okay. Now, we said there were 2 types of friction, static friction and kinetic friction, right? So the question is, could we measure kinetic friction this way? It's a little harder, admittedly, but it is highly doable. And so what we would do, again, is we know that kinetic friction is always less than static. So we would expect that the angle would be less than 13 or 12 and a half degrees. So how do we get that? What we have is a hump we have to overcome, and I should have put it on the board. I'll do it in a little bit of a video later to do that. So what I'm going to do is I'm going to tap it with this as I rise. I'll tap it at 10, and I need it to just inch down very, very, very slowly. We're using no instrumentation than our brain and our skill to do this. So, okay, I've got it at 70. I'm going to bring it up to 10, and then I merely touch it like that. One good tap. Did it move at 10? No. How about 11? Not moving. I tapped it. Did it continue? No. I'm going to put it back in place. Raise it up to about 11 and a half. Tapped it. It appears to be moving fairly slowly, but I can detect it's going a little faster. But I know it's got to be between 11 and 12 at this point. So what would I do again? I take this back down. I know I have to start at 11. I want to make sure it's stable. I go ahead and whack it. Nope. 11.5. And it appears to be moving on its own. Nope. 11.75. Possibly from the fact that I didn't hold it when I was moving it, just gave it enough energy to go over the tip. And you can see that it's very, very slowly moving. So I've isolated it between 11.5 and 11.75. More experimentation, being more careful, and I've got my point, all without instrumentation.